integration to be 0. Of integration to be 0. Okay, so to be 0. To be 0. So this is the first step. Okay. The first step is you need to calculate the integration factors. Okay. The integrating factors mu equal to e to the power the antiderivative of px. So this is the first step. So the second step, okay. So the second step is so here is dy dx plus pxy equal to qx. So here the second step is multiply, okay? So multiply the equation dy dx plus pxy equal to qx. Multiply this equation, okay? This equation by mu on both sides, okay? So here we have, from here we have mu dy dx plus mu pxy equal to mu qx, okay? Mu qx. And you express it. And you express it by d dx mu y. Okay, d dx mu y equal to mu qx. So actually from here we can see this step, actually this step, okay, this step. So this is the second step. So the third step actually is integrate both sides. Integrate both sides of the equation d dx mu y equal to mu qx. So from here we can obtain the y actually equal to 1 by mu the antiderivative of mu qx dx. So this is the result. Okay, so this is the result. So this is the step. Okay, this is the method. So this is the method of integrating factors. Okay, integrating factors. So here, I hope that you can remember this three steps. Okay. So the first, we have two key points. Okay, two key points. The first point is you need to remember the integrating factors. Okay, mu. The integrating factors mu is e to the power the antiderivative of px. So here px is what? Here px is this px. Okay, is this px. The first key point. The second key point is you need to multiply this equation on both sides by mu, and we obtain this equation, and express this equation in this form. Okay, in this form. So from here we can see it's easy to see that how to find y. Actually, you just need to integrate on both sides. So here we can find y equal to 1 by mu, the antiderivative of mu q. Okay. So this is the step. So now we have a question. For example. So here this is for this equation. Okay, for this equation. So now if we have a question, or if we have an equation like this, capital Px dy dx plus qxy, capital Qxy equal to Rx. So for this equation, for this equation, okay? How to find the general solution of this equation? Here, now we can see for this one, okay? What's the difference? What's the difference of this one and this one? Here, now we can see here is dy dx plus pxy equal to qx. This is what? This is px dy dx plus qxy equal to I. So what's the difference? The difference actually is here is 1. This constant is 1. This coefficient is 1, but this coefficient is px, yeah? So this is the difference. So actually we can, if we divided px on both sides, okay? If we divided px on both sides, so here actually is we can transform it to dy dx plus qx divided px equal to what? Times y equal to rx divided px. Yeah? So now we can see if we divide the px on both sides, this equation reduce this equation. This equation actually is in this form, yeah? So we can use this method, okay, this method. So now, I think, this equation actually is important, okay? Of course, I will test it.
Which one?
In the final exam, okay? In the final exam, I will test this equation, okay? So now I give some examples. I give some examples. Now, so this equation, dy dx minus y equal to e to the power of 2x. So here now, actually we can see this equation actually is in the form of this equation here with px equal to what? Px equal to minus 1, yeah? And qx equal to what? E2x power, yeah? So now we need to find this equation, the solution of this equation. So here we use this method, okay? This method, the first step is we need to find the integrating factors. So integrating factors mu actually is e to the power, the antiderivative of px dx, yeah? The first step is compute the integrating factors. So the integrating factors actually is mu equal to e to the power the antiderivative of px. For this equation, px actually is minus 1, yeah? So here we e to the power the antiderivative of minus 1 px. So the antiderivative of minus 1 actually is what? Minus x, yeah? So here actually is e minus x. Minus x actually because the antiderivative here should be plus c, okay? Plus c, but here we can see we take the constant 2 of the integration to be 0, okay? So here we take c equal to 0. So now, the first step we compute the integrating factors e to the power minus x. So the second step is what? The second step is we times the integrating factor. We times the integrating factors on both sides. Yeah, on both sides. So the second step is dy dx minus y equal to e to the power minus e to the power 2x. So we times e minus x power on both sides. So here is e minus x times dy dx minus e minus x y, yeah, equal to e minus x times e 2x power, yeah. Here, now we can see e minus x times e 2x power actually is what? Is e minus x plus 2x power, yeah? Plus 2x, minus x plus 2x actually is x. So e to the x power. So now at the left hand side, okay, the left hand side, actually we can see here actually is what? Here actually is e minus x dy dx. Here minus e minus x. Minus e minus x actually is what? Is d e minus x dx. Yeah? Times y. Yeah? Times y. So this is equal to what? This is equal to e x power. Yeah? So now we can see ex dy dx plus ex plus y. So the left hand side actually is what? Is d dx e minus x power times y equal to ex. Yeah? Here, the left hand side actually is e minus x power times y. This final derivative, okay, derivative actually is the left hand side.
Not how we get this?
Here is e minus x power dy dx. So this is the first term.
Yes, okay.
So here
Yes.
minus e minus x actually is dx dx. The plus e minus x power actually is minus e minus x power.
Oh, yes.
So here we replace this part by d e minus x dx. So here for this, from here we integrating on both sides. So here we have e minus x times y equal to the antiderivative of ex dx. Yeah? So the antiderivative, okay, so the antiderivative of ex actually is what? The antiderivative of ex is ex, yeah? Ex plus a constant c, yeah? So here we times ex on both sides. So here we have y equal to what? Y equal to ex times ex plus c. So actually it's e2x power plus c ex. So this is the general solution. Okay, this is the general solution. This is the first. So here, I hope that everyone you can familiar with this method. Okay, familiar with this method. This method means the method of integrating factors. Okay, integrating factors. So here, this is the first. So now we can see here we have a constant c. Okay, we have a constant c. We have a constant c here. So sometimes we need to determine the constant c. So actually we should to give a condition. The condition actually is sometimes means y x0 equal to y0. Okay, y here means set. So here means when the curve, okay, the curve passes through the point x0, y0. So when x equal to x0, y equal to y0. So if we give this condition, okay, if we give this condition, we can determine the constant c. So here actually we have another problem means the so here for this one, okay, so here means that the first order initial value problem. The first order initial value problem, okay. So here dy dx plus dxy equal to qx, okay, equal to qx. So this is the first order. This is the first order differential equation, okay. First order differential. First order differential equation. This is the first, okay. The second is here. Yx0 equal to y0, okay. This condition means when x equal to x0, y equal to y0, okay. So this equation, no. This condition actually is used to determine the constancy here, okay. Determine the constancy here. So this here we have a name. This means the initial condition, okay. Initial condition. So here we have the differential equation and we have the initial condition. So these two we give a name is the first order initial value problem, okay. The first order initial value problem. So here means the first order. So we have the first order differential equation. The second is the initial condition. Okay. So here means the first order initial value problem. So the first, okay, the first. So now, for example, for this one here, for this one, if we give. For this one, okay, for this one here, if we give dy dx minus y equal to e2x power and the y0 equal to 3, okay, y0 equal to 3. So for this one, the first is the first order differential equation. The second means when x equal to 0, y equal to 3. So the second condition actually is the initial condition. So this problem actually is the first order initial value problem. Okay, the first order initial value problem. So here the y0 equal to 3. So here means when x equal to. So this condition used to determine the constancy. Yeah, because now we can see this equation, okay? This equation and this equation, they are the same. So here means that. So here means the solution of this equation actually is what? Is here, yeah? Is here is y equal to e2x power plus cex power, yeah? So now we need to determine c, okay? We need to determine c. So we let x equal to 0. We let x equal to 0, y should be equal to 3. So here means that 3 equal to e2 times 0 power, 2 times 0 power plus c e to the 0 power, yeah? e2 times 0 is 0. e to the 0 power is what? 1. So here equal to 1 plus c times e to the 0 power, 1. So 3 equal to 1 plus c times 1. So c equal to what? C equal to 2, yeah? So equal to c equal to 2. So here means this c actually is 2. So here, so y should be equal to e2x power plus 2ex power. So this, okay, so here this is the solution of this first order initial value problem. Okay, this is the solution of this first order initial value problem. So actually this initial condition, okay, this initial condition actually is used to determine the constant c. Okay, the constant c. So now I give another example. So example. So the initial value problem. So the initial value problem x times dy dx, x times dy dx minus y equal to x, and y1 equal to 2, y1 equal to 2, okay, y1 equal to 2. So here, so now we need to solve the initial value problem. This is the initial value problem. Here we have Vx, x times dy dx minus y equal to x, So now we just it's in this form, yeah. We just introduce the method. The method is vivid for this equation, yeah. Here this coefficient here should be 1, yeah. But here should be x. So how to deal with this x? How to deal with this x? We should divide x on both sides, yeah. But we divided the condition is x cannot be to 0, yeah. X cannot equal to 0. So here, so x cannot equal to 0. So here means that we should do to study in the interval from 0 to plus infinity, or from 0 or from minus infinity to 0, or 0 to plus infinity. Okay. So here we should do study this equation because we need to divide the x on both sides. So x should be not equal to 0. X should be not equal to 0. So here means that we should study the equation on this interval or this interval. But here we can see the condition. The initial condition actually is y x equal to 1. X equal to 1. Actually 1 is in this interval. 1 is in this interval. So we just need to study this initial problem on this interval. Okay. So here now we can see 4x belongs to 0 to plus infinity. 4x belongs to 0 to plus infinity. We divided x on both sides. Okay. So here we divided x on both sides. This equation. So here actually is dy dx minus 1 by x y equal to 1. Yeah? Here, x divided x actually is 1. Yeah? And here is minus 1 divided x. So minus 1 by x, 1. So here we have this equation. So this equation actually is px equal to what? For this equation, px is what? Px actually is minus 1 by x. Yeah? And qx is what? Qx is 1, yeah? Qx is 1. So we need to find the integrating factors, okay? The integrating factors mu. So now here, we need to find the integrating factors mu. Mu actually is e to the power, the antiderivative of px. The antiderivative of px, So here px is minus 1 by x. So here is actually the antiderivative of minus 1 by x dx. So here now we can see the antiderivative of minus 1 by x dx equal to what? Here minus actually is can move through, yeah. So minus the antiderivative of 1 by x. So it's what? Minus log absolute value of x, yeah. So here because we just study this interval, x belongs to 0 to plus infinity. So here means x is positive. So the absolute value of positive is either side, yeah. So here is minus log x. So here actually is e minus log x, yeah. E minus log x power, e minus log x power actually is what? Is 1 by e log x, yeah. So e log x is what? E log x equal to x, yeah. So here is 1 by x. 1 by x. So here means that the integrating factor, okay, the integrating factor is 1 by x. So now we need to times 1 by x on both sides, okay, on both sides. So here dy dx, so dy dx minus 1 by x y equal to 1. So now we times 1 by x on both sides. So here is 1 by x dy dx minus 1 by x square. 1 by x times 1 by x. So 1 by x square y equal to 1 by x. Yeah? So now we can see here, okay, this is mu. Actually, this is what? This is mu derivative. So here, because 1 by x, this is 1 by x dy dx, and minus 1 by x square actually is 1 by x derivative. Okay, derivative times y equal to 1 by x. Yeah? Here. This is mu, yeah? This is mu, and this actually is mu derivative, okay? This part actually is mu derivative. So here is 1 by x derivative. So 1 by x, so the 1 by x here, so here we can see d dx 1 by x times y. So the left hand side actually is, so d dx 1 by x times y equal to 1 by x. Yeah? So here means what? So here means the derivative of this function equal to 1 by x. So this function actually equal to the antiderivative of 1 by x. So here 1 by x times y equal to the antiderivative of 1 by x dx. So the antiderivative of 1 by x is what? It's log absolute value x, yeah? Yeah?
Yeah.
So log absolute value x, because Vx is in this interval, so here actually is log x. So from here now we times x on both sides. So here we have y equal to what? Y equal to x times log x. X times log x. Of course, no, I'm sorry, here should be plus the constant c, okay? So here plus the constant c. So the result actually is x log x plus cx. So this is the general solution, and now we can see when x equal to 1, y equal to 2. So here now we can see we replace. So y equal to 2. When x equal to 1 times ln 1 plus c times 1. Ln 1 is what? Ln 1 is 0. So here is 0 plus c, so equal to c. So here means c actually is 2. C actually is 2. So the result actually is y equal to x times ln x plus 2x. So this is the result. Okay. So here I hope that you can remember the step. Okay. If you cannot remember the step, okay, but I hope that you can remember the formula. Okay. So the formula is what? So the formula, okay. So now I give you the formula. So the formula here is dy dx. So for this equation, dy dx plus pxy equal to qx. For this equation, y actually is 1 by mu times the antiderivative of mu qx dx. So here mu is what? Here mu is e, the antiderivative px dx. Okay, so this is the formula. Okay, so this is the equation. So the solution, the general solution. Okay, so if you can remember this result, it's okay. Okay, but I think that it's not very easy to remember this result. Okay. What? So this is the formula. Here is 1 by mu. Mu is e to the power, the antiderivative of px.
Because we are finding this one.
Yeah.
Then we know y is 1 over mu.
Yeah. 1 over mu, the antiderivative of mu qx
X
dx.
dx.
Yeah.
Then you can find the first without all this you can find the
So first you should do find mu.
yes, how to move this.
Yeah.
Then you can find the derivative of this one. You can take this one.
So you need that from here I give this result.
Yes, from here.
Yeah, of course, it's the same. So I show you. Here from here. Okay, from here first, we compute mu. Mu is what? We compute mu. Mu actually is 1 by x. Yeah?
Yes.
Mu is 1 by x. So here is, so from here is y equal to 1 over mu. Mu is 1 over x. So here is 1 over x. Yeah? And here is mu is 1 by x. Q is what? So Q is 1, yeah? Q is 1, so times 1, so dx. Yeah? So 1 over x actually is x. Yeah? And the times the antiderivative of 1 over x. So here is x, here is the ln absolute ux plus c. Yeah?
Very easy option.
Yeah. So yeah, this is the two examples. So now I will give you two exercises. Okay, exercise. So now the first one and the second one. The first one, dy dx plus 4y equal to e to the power minus 3x. The second one is dy dx plus 2xy equal to x. Now do it, okay? So do it now, okay? The first one, the second one, so do it now. You can use the formula, okay? Of course, you can use the method, okay?
X minus 1 part divided x minus 1 part divided minus x minus 1 minus 1 yeah. So it's minus x minus 3 part. X minus x minus 5 is minus 1 by x squared yeah. So here this one so here this is the function. So here 1 by x times y part yeah. So 1 by x times y part plus here is 1 by x squared times y yeah. So here is 1 by x squared so 4 plus yeah. Yeah. So here I think here this should take c equal to 0.
So why is it c equal to 0? Yeah, then over here this myself.
Here we can take the constant of the equation to be 0 in this step. Okay. So here this step.
So have a break. 30 minutes. Okay.
I have to do